Hello everyone, this is Charan. This is regarding icp9 Big Data Analytics assignment. The goal is to create a linear regression model which has which showing the SSE, sum of squared errors and the mean squared errors and y-intercept, slope and the other values. So quickly talking of the data set, I've hold this data set in the Google Drive of mine and the fuel consumption, and then used gdown library to download it at the runtime. So a quick view of the data frame after loading it as a data frame is these are the different variables, and we are trying to understand what is the CO2 emissions based on these multiple features. This is multiple linear regression. And in the first columns, as a part of exploratory data analysis, I am checking if what are the values, like any null values that are observed. So I'm dropping them, which is in place. So the fuel data frame will have no null values after this. And I'm also describing the data to see what are the different means, averages, and other data that we see in different types of emissions. Before going on to the prediction part, I've done some static analysis to understand the data. I did a quick plot comparison, the class versus emission. So I found that van and the passenger vehicle is the one highest emitting carbon footprint of all the different classes that are available. And then the next one I did what is the average engine size and the emissions ratio, seeing that engine size of 6.8 leads the carbon emission compared to the rest of them, which proves engine size is not necessarily the size that leads to the carbon emission. If you see 8.4 has been on the lower side and 6.4 is on the lower side. However, we see 4.2 as a higher side, which also means maybe there are more vehicles in 4.2 and 6.8 version of engines which are old, which are leading to carbon emissions on the higher ratios. The next comparison I did is with the make of the vehicle and then carbon emissions. Surprisingly, it's not the number of cars. I think the Aston Martin, Bentley, Lamborghini, and Rolls-Royce and SRT are leading in terms of carbon emissions. That's because maybe the manufacturers are more focused on acceleration and the top speed over the efficiency of the fuel consumption. So here are the few categorical variables that we see in this data frame. So we have to remove the categorical variables because categorical variables does not lead to the prediction of the linear values. So a small example is given demonstrated here. If we are to represent X feature as categorical variable, Lamborghini as 1 and Honda as 2, calculating Y in a linear regression fashion would result CO2 emissions of Lamborghini as 3 and Honda as 4, which is not right because categorical is not the quantitative or the qualitative measure of the class. It's just a representation, so which doesn't work well in the linear regression. So I had to drop those values, which are these values, and then based on that I've taken the data frame values and I've used the final field as a prediction, as we can see here, CO2 emissions as a predicting factor. Here is the locations where I've test train and slipped of 80-20% and then done the linear regression. And here are the slope and the intercept because there are multiple features and there's a multiple linear regression. There are number of coefficients, number of slopes. So that slopes are being calculated here. Going to the prediction error and errors, I have done mean absolute error, which is not squared, just the subtraction between the prediction and the actual values and doing an absolute values of that and calculating the mean. And there is another version, the square mean squared error, and there is also root mean squared error and also sum of squared errors. All of these have been calculated and presented here. As a conclusion of this, linear regression is very simple in its implementation, but it's not very efficient in terms of non-linearity. So the very data fabric, the data has a very fabric nature in which non-linearity has been observed. So in the real-time predictions, maybe linear regression is not a right value or the right technique to observe the predictions. Now let me run a quick run and see how this runs. So this, at the time this is getting downloaded, as we can see, this is still getting processed, and it's quite fast. So it has already completed all the runs and mean squared array is in. Let me run another time. You can see this running. It's calculated now. Thank you.